So we're gonna go over some of the things we did wrong that are easy things to solve. So first of all, going over the liquid helium transfer, it's important for this cap goes on top of the liquid helium tank, and it's important for this black O-ring to be in there. Otherwise, you'll have a leak, and it won't transfer as quickly, and you'll lose helium. So make sure that this is inside of this cap here, so it seals the contact. And so another thing is this persistent current here on the magnet down here. It's important to whichever magnet, if you're using the perpendicular or parallel fields, to make sure that whichever magnet you're going to ramp up the heaters on, so that essentially it unshunts the circuit and allows you to send current down the coil to ramp the field up. So make sure that that's on if you're going to use the magnet.
Yeah, once we run overnight for the program, and in the morning found that it's the same magnet field. Right?
It didn't change. Even though the program said it was changing, nothing happened because the heater was on. Right. So a couple other small things with this program. So when it's possible to run multiple lines of code when running this program. So when you edit run program, though, you can if we have a second line here, make sure that you want to use this plus command. To put a plus after the line, the first line will automatically go to the second one and run the second line here. But you have to make sure that there's a space between this plus and the end of the first line. And so we made the mistake of not putting that space there, and of course it didn't work. So just some nitpicky things about Venkat's program. And so another thing is with this trap, the liquid nitrogen trap, you can already see there's ice on top of it right now. And so when filling it, it's important to, especially if you fill it to this hole right here, that so right now this hole is blocked with ice. You can look in there and see it. So it's important to make sure that hole is clear, and make sure that there's no water on this thing when filling it, because the water is going to freeze and form ice, and then it's going to block things like that. So so just mop the water off the top of it before you fill it, and be careful with this condensation, because you can easily just freeze in the top of it.
Right. Yeah. So one way I use to avoid this is just lift the whole cap above and then fill from the side. Yeah. Right. Yeah. Then it's safer. Okay. Good.
And then one final thing when taking measurements, we've had the problems. These T's, if you ever use for example, something like this. If you ever split it with these T's when connecting things, a lot of these sometimes can either have shorts in them or something where you'll get a weird signal, and it's bad contacts.
Right.
And so you can be careful when using these, because sometimes you can mess up your signal.
Right.
And you won't know where it's coming from. You just find out it's either one of these T's or
and the locking keeps saying overloading. Right.
Yeah. It's really annoying. So that's about all all the problems I can think of we had so far. So.
Okay. Good.
And then thunderstorms too, which Jen's going to talk about.
Okay.
So, okay.
Yeah, last few days there was a tornado and the thunderstorm, and also I get a haircut. My wife
you see that?
So when there's thunderstorm, sometimes there's a power shutdown, and we have just two pumps, helium 3 pump and helium 4 pump downstairs, and for the whole system, and they went down. So we lose this cooling power because we need to keep pumping to get the circulation, to get cooling. So all the mixture comes back to the dump, and the temperature goes up, the system warmed up. But also we need to be a little bit careful about this instrument rack, because after this power shutdown, a lot of the equipment will reset themselves, right? So we need to be sure that it's in the correct state. Maybe we need to buy like a UPS, especially for this power supply for the magnet, because when I come in, it says it's in a faulty state. But if you're running the magnet, you have like a 10 amp or 50 amp of current, then there's a lot of energy there, and it might get something, might damage something when there's a crash happens. So remember to sometimes this catalytic, which we use to program the magnet, after power shutdown, the output will be off. So we need to remember to press this operate button. And for this power supply, when it's in the faulty situation, you need to restart this power supply to get out of this, so to speak, faulty situation. And then you will unpress the standby button to get it work. And also this one, it will say it's a bad communication. So there's a problem with communication. And then you just press DC read button. And here, the synthesizer is also a little bit tricky, because we need to, usually we want to ramp using this sawtooth wave, but the default model is sine wave. So after power shutdown, you need to reset to this sawtooth mode. And also remember to set this amplitude of this ramping amplitude, because we first need to set amplitude larger than what we want, or larger, a little bit larger than what we want from in this programming. Because otherwise it will stop. Yeah, that's it.